Hi everyone, welcome to this new tutorial. Today I'll teach you how to make a desktop game in JavaScript. So JavaScript is usually used for the web, but with a technology called Tauri, we're going to be able to make a game that is installable on your PC. So we're going to use Tauri and the KAPLAY library. If you don't have any experience with both of them, I'm going to explain everything. So this tutorial is really for you. In a sense, the only prerequisites you need is a good fundamental understanding of JavaScript. Now, let's get started. So the game I'm going to build here is a Flappy Bird style game. So you jump here, and then when you hit the obstacle, you have your previous best score that is always written to disk. So you have the concept of a save file. And this is something I wanted to teach you because this is one of the main draw of having a desktop game in JavaScript, is so that you can save your games. So usually JavaScript is used for the web, and in the web, you have local storage, but it isn't a very safe way to store data because as soon as the player clears their browser cache, it's going to wipe out the save. So this is one of the main draw of having your game as a desktop game if it grows above a certain size and you need to keep track of save data. So let's jump right into it. So in this game, one thing I forgot to mention is that we're going to have multiple inputs. It's going to be a very simple game because I want to focus on the actual Tauri concepts and the KAPLAY concept. So KAPLAY is the library for making games that is very easy. It was called Kaboom.js previously. If you want to know why the rebrand, you can watch the previous video. By the way, I made a lot of tutorials on Kaboom.js and how KAPLAY basically now, how to make games with it. So if you're interested, feel free to watch those as well. They are still relevant because the difference between KAPLAY and Kaboom is just the name for now. All right, so here we're gonna implement keyboard controls. So just by pressing the space button, you can jump. We're gonna also implement mouse control. So by clicking, you can jump, but also gamepad control. By pressing the south button, you're gonna be able to jump. So this might sound strange. What is this south button? So look at this little schematic. Imagine this is a controller. The south button is the action button that is always at the south here. So it's a way that KAPLAY uses those terms so that it can be independent from the actual type of controller. So an Xbox controller versus a PlayStation controller have different symbols on them. But at the end of the day, the X button is here for the PlayStation, and for the Xbox, I don't remember actually. Here, is it A or B that is down there? But by just using the south name, we can just have our game be agnostic regarding this. So let's start the project. So there are some prerequisites that you need to have. So in terms of following this tutorial, you only need to know JavaScript, the basics. But as for the installation process, and also, by the way, I'm going to do this mostly on Windows. So the reason I'm doing this on Windows is because this is the machine I have. And also, the expectation for games is usually that they run on Windows. So if you're going to publish a game on Steam, it's really not worth your time to support Linux and macOS usually. Now, maybe with Proton, with the Steam Deck, it's changing a bit, but yeah. So you need to follow this this page. So it's going to be linked in the description. It's the prerequisites. So you need to set up this on Windows. By the way, you can still follow this tutorial on macOS or Linux. There are some instructions, but at the end of the day, the executable you're going to get is not going to be the one for Windows. So here we're going to set up Windows. Here I have the link in the description. Follow the instruction here. You have a few things to install. So one thing I want to mention is the WebView 2 thing. So Tauri, compared to Electron, which is another solution technology for basically making desktop apps using JavaScript, HTML, and CSS, is that with Electron, it packages a whole Chrome browser for each version of your app. So if it's on Linux or macOS, etc., it's always going to package a fixed version of Chrome. And the advantage of that is that your app is going to be rendered the exact same way regardless of the platform. However, the drawback of this is that it's going to make your app bloated. So because Electron has to package a whole Chrome browser, that means an executable that does basically nothing So a project, empty project is going to be, I think, 100 megabytes. Now with Tauri, the actual end game, like the full game that I've shown you earlier, is only 6 megabytes. So you can see that it's really not bloated. And the way Tauri achieves this is by using the system's web view. So for each operating system, they have a web view that Tauri uses. But the issue with that is that you cannot really make sure that the app is going to be rendered the same way on all platforms because, different browser engines have different particularities. It's mostly the same, but it's not exactly the same. The reason I'm going to use Tauri for this tutorial is because it was very easier to set up than Electron, less bloated since on Windows and also on other platforms. But the most important aspect that basically determined that I wanted to use Tauri instead of Electron is the fact that I really am targeting Windows only for this project. So I don't really care or feel any of the drawback of the fact that it's not exactly the same browser engine on the various other platforms because I'm not publishing to other platforms. All right, so once you follow this, you install. And by the way, another drawback, perceived drawback, is that it needs to have this WebView 2 runtime installed on the user's machine that is going to use the app. But now it should be available on all Windows 11 operating systems, distributions, but not on Windows 10 or Windows 7, I think. And then the reason for that is, well, it's not available by default. And if you were to just distribute a .exe made with Tauri, then this would be an issue because you would have to make sure that the user has the WebView 2 installed on their machine. Now, this is not an issue in the end because we're going to distribute the installer, the MSI. And this installer that we get after building the project is going to install this WebView 2 runtime on the user's machine if it's not already available. So you don't have to worry about anything. And yeah, you need to install Rust, even though in this tutorial we're not going to use it really. We're just going to, well, we're going to write some commands, but we're not going to write Rust, basically. It's just the project itself is built with Rust because there's a JavaScript API that can use to read and write to a file, which makes it very beginner friendly, I guess. All right, so follow this, and once you have followed the prerequisites for your platform, let's jump right into the project. All right, so how do we start a project? So also you have to have Node.js installed. This should have been mentioned in the prerequisites link that I've shown you earlier on. So you need to run npm create tauri-app at latest dot here if we're in a folder. So I'm using VS Code as my editor. I have created this Creeby folder because Creeby is the name I've chosen for this project. And then once I'm in this project, I can use the dot notation here so that it's going to create the project files within the current folder I'm in. If you were to omit this, it would create a different folder for you. So run this command. And then maybe I should increase the font size already, just to make sure that everything is visible. And then the package name. You have to specify your package name. I'm going to call it Creeby tutorial. Actually, just Creeby. I'm going to use TypeScript and JavaScript. This project uses JavaScript, but you need to use like which one for your front end you want. And then npm. And then here, do not select the vanilla UI template because the vanilla UI template is just going to be a build-less HTML, CSS, and JavaScript. So we still need to use a build system because it's more convenient to install and use the Tauri API that way. So I'm going to take the React template, but I'm going to remove everything that is related to React for this project. And then choose JavaScript here. All right, so we have everything we need. Now I'm going to open up the package.json and you can see that we have a couple of dependencies we're going to need to remove. So we're going to need to remove React and React DOM because we're not going to use them. So I'm going to type in npm uninstall React and then React DOM. All right, the package have been uninstalled. And then I'm going to also uninstall this VGS plugin React. We don't need that as well. So I forgot to do that. So let's do it. Here we go. npm uninstall. Here we go. And then that's it. And now we can install the KAPLAY library. So KAPLAY can be installed in many different ways. It can be installed using a script tag, much like I did with Kaboom.js. But for this project, since we're using Vite inside of it, we're just going to use npm. npm install KAPLAY, and I'm going to install a specific version. This is, I'm making sure to pin the version here so that if you're watching this in the future, it's going to always work. This tutorial at least. So it's self-contained. So 3000, that's the version 0.1.17. If you're not familiar with KAPLAY and Kaboom, it works in thousands. So version 1.0 is actually version 1000, version 2.0 is 2000, version 3.0 is 3000. This is the naming convention that I used. It's strange, but I don't know the reason why, but yeah, that's it. It is what it is. So I'm going to hit npm install KAPLAY with this version. Now we have KAPLAY installed. Let me check in the package.json, and here we go. Okay, so before we do anything, I'm just going to collapse this. I'm going to collapse this as well. And I'm going to go to here. So here, to run Tauri, you have this Tauri command. Just to make things convenient for us, we're going to rename those commands. So we're going to have dev dot browser and dot browser here to differentiate from the two other commands I'm going to write here. So I'm just going to do preview. This is just a name I have decided for myself. But here, instead of having Tauri here, we're just going to have, when I run npm run dev, I want to run Tauri dev, which is going to actually start the application. And the reason we're doing this is because we have two systems going on. We have Vite, which is a bundler that bundles your web code and then puts it on a local host that you can use. And then there's Tauri, which takes this output at the same time and puts it in a desktop window. So that's why we have those two commands, even though for this project, we're not going to use Vite directly like that. We're going to use Tauri dev. So the other command is build and Tauri build. So just to check that everything works, but because we are using the React template, I'm going to remove everything that is within here. So let's remove all of those files. I'm going to also remove everything within the within the public folder. All right, delete this. All right, now we have the index.html. We don't really need much here. I'm going to remove this. I'm going to remove the head tag. I'm going to remove the HTML. I'm going to remove even this. It doesn't matter. And then here, instead of JSX, it's going to be JS. And then in the source file, I'm going to create a main.js file. Now in main.js, I'm going to call what we need for KAPLAY. So I'm going to import KAPLAY from KAPLAY. And then, and then here, I'm going to initialize the KAPLAY context, which is basically creates the canvas for us. You call the KAPLAY function like that, and then pass in a bunch of options. The width of the canvas is going to be 1280 by the height, which is 720. And then here I'm going to use the letterbox options. Those are all options that comes from KAPLAY. So here, letterbox true makes our game will scale regardless of the window size while maintaining the aspect ratio. And then here I'm going to put whether or not we want this to be global to be false. So we don't want KAPLAY functions to be available globally. We want all KAPLAY functions to be callable from the context. This will make our code cleaner. And then we want to scale the canvas 2 times. This is what looked good. And then this is for everything within the canvas. It's going to become relevant later on. So let's do that. Now let's go back to the terminal and run npm run dev. And then here it's going to compile your project. And then you're going to have to wait a bit before it compiles. And usually if you modify things related to Tauri config, I'm going to go over the file here, then the application will have to close and reopen. Otherwise, if you just modify JavaScript content here, code here, it should usually hot reload. I have something messed up. I need to modify something in the Tauri file here. Yep. Here you should run the dev browser and then build browser. And so really the preview command, it doesn't matter. So I'm just going to cancel this out and then everything should work. All right. So if I do this, and then, okay, what's the issue? Cannot find the package VJS plugin React. So here, let's remove everything related to React in the vite config because we have removed it. So everything should be like that. And now, just so you can see, I removed this and another option called plugin React. So now let's run it. Hopefully it works this time around. Yep. When you see localhost, and then it's compiling, and then downloading the various crates we need. This is only done the first time, I think, and then it's building. Yeah, so it might take some time. It's a bit slow but this is only like the first time. All right, so it was a bit slow, but it's the only once you do this, and then now it should hopefully open up. And here we go. We have our window with our canvas, and then if you press F12, so let me just increase that a bit. If I press F12, you'll have your console. Ignore this, we just remove the favicon. It doesn't matter since it's a desktop application. And yep, so we're ready to start working on the game. So let's import our assets. So I'm gonna close this. By the way, you can just leave it open like that. So here we go. I'm going to go here, and for the assets, we're gonna put them all in the public folder. All right, so I have imported all the assets. You're gonna find a link in the description or multiple links in the description to get everything here. So I'm gonna go over everyone. So this is the background.png for our game, clouds. We're gonna have a colliders data.json, which basically defines the hitbox for every platform obstacle. So the height and width of that hitbox and where to put it. So the X and Y coordinates. This is better. I thought it would be better than having to pull an external editor like Tiled. If you are interested in how to make like more serious games using an external editor called Tiled, watch the previous tutorial I made on the channel. Here are a few sounds. We have the confirm sound. So when you click on the button, the hurt sound and the jump sound, those are made using a website called gsfxr.org. I think that's the name. It allows you to make 8-bit or 16-bit sounds. And then we have the sprite for Creepy, and then the obstacle layer here. So the obstacles. And then one thing also is the icon. So here you can provide a bunch of different icons, and there's an icon command in Tauri. But for this project, since I only care about Windows, I just imported this icon for my project. So you'll find this in the description. Just put it under the source-Tauri and then icons folder here. All right, so if I look at the project, you can see the icon appears here now. All right, I'm gonna minimize this, and we're ready to start working on our project. So let's go back to the source folder and then in main.js. So the first thing I'm going to do is to actually load a bunch of our assets. The way you do that in KAPLAY is to call either the load sprite function or the load sound function. There's also the load font function, not font, font, sorry. So load sprite works this way. So you pass in the name of the sprite you want to use. So creepy, this is going to be the key that we're going to refer to in our code base. And then the second param is the actual param. So the param here is going to be the path to the assets, which is going to be creepy.png dash creepy. So the reason it's just a dot dash is because when working with Vite, the public folder will automatically be linked to the root of the project. So you don't have to write public slash creepy.png. So that's the first one, and that's basically it for the sprite. So I'm going to copy and paste the rest that you need here. So load sprite obstacles, backgrounds, and clouds, much the same way. For the sounds, it's similar, but the only thing that changes is that you use the load sound method instead. All right, one thing I want to implement right off the bat is to allow the player to go into full screen. So for now, if you press F11, which is usually the keyboard shortcut for going full screen, well, it doesn't work. So to implement this, we're going to have to use the Tauri API. So Tauri allows you to use a JavaScript API instead of Rust if you want to do things that touches the native like Windows system, like the native app system. So writing to a file, changing the full screen, etc. Those are things handled by the game window itself. So you have this file called tauri.conf.json, which handles all the permissions to what you're allowed to do. All right, so you have a bunch of permissions, and the permissions we're going to use here, are going to need to edit, is two things. So here in our tauri.conf.json, go to the Tauri and then allow list property. And then here, we're going to have two things. So we're going to use the fs key for file system and allow us to read the file. So set this to true. To write to a file, set also this to true. And the scope. So the scope is here is, let me just put it scope, and then I'll explain it. So, and then add a comma. So what is this? Later on in the project, we're going to need to write the save data, the save files, basically. So this is a score, actually. We're going to need to write this to disk so that when the player plays again some other time, we know what their best score is always. And for that, we need to be able to write to a file and read to a file. And here, the way Tauri works is that you need to enable each permissions. Either you enable everything by using the all property, or for each of those APIs, you enable what you need. And usually the best practice is to always enable what you only need. And the scope here is the files, the folder you're going to have access to only. And here, we're going to need to pass in the app local data folder, and by having this notation, so everything in the app local data folder is going to be accessible to our Tauri application. So we're going to be able to write to any file write to any file within that folder, or read any file within that folder. And the .star here is for that as well. So here, this constant or this name comes from the Tauri documentation. There are various constant like that, and it refers to if you go on Windows and you type in run in the command start, the Windows, the search bar on Windows to the left, and you type in run, and then here you type in app data, and you have a local, low, and roaming. And if you go to the local folder, this is where maybe you're not seeing it. Maybe I can zoom. Yep, I can see. So in this local folder, you're gonna have a folder that is the name of your application, and in that folder, everything you can read and write within that folder. Let's replace this with creepy.game, and then if you do this, if you refresh, it's going to rebuild it. Here you can see that we have this, if you look at the path, app data local, and then creepy.game was created automatically by the application when it runs for the first time, or when it is installed. So here is everything. We're gonna write the save file here. We're gonna read it from here, etc. Hope that was clear. So now, yeah, replace the identifier, make sure everything is saved, and the other permission we need though is for the Windows permission. So window permission, and the exact permission we need to be able to set this to full screen is the set full screen permission, and I'm gonna set this to true. So now if I go back to main.js and I go here down below, we can write the logic we need to make the window go full screen when the F11 key is pressed. So I'm going to add an event listener. So you can do this in two ways. Either you do document but add event listener, or you can just call add event listener directly like that. And then here the key down event we want to listen to. And we need an async here because the API, the Tauri API is asynchronous. So here we're gonna have an EV for the event, or you could call it event if you want. And then here, if the event code equal F11, so that means the key was pressed. So actually here a better name would be the key, and then key.code is F11 key. If this is pressed, we're going to have first an if statement that is going to call this API. So app window, and you can see here, app window, it's going to import it from the Tauri API. So click on that, it should import it at the top of your file. And then here, what will happen is that first you check if it's full screen. So is full screen, you use this. This is from the API. If it turns out to be the case, then we're going to set it back to not being full screen. So the F11 key acts usually as a toggle. So we can use the set full screen function that we allowed the permission for in tauri.conf.json to turn it off. So with false. And then we have another if statement here. Actually, we should return early. So if I have this like that, I put it within brackets and we return early. And then here down below, if that was not the case, that means that the app window is not full screen. So I can just do app window, and of course don't forget to await. Well, actually it's not necessary to await here because we don't do anything afterwards. So set full screen and then set this to true. So here we needed to await so that we don't move on, we don't return before we are sure that we don't return before we are sure that the app was set to full screen. In this case, I don't think it really matters, but here it would matter because otherwise it would return a promise and not the actual value. So yep. Okay, so let's test it out. So I'm going to open the application. It is here. Now I'm going to press F11 and we can see that it is full screen. Now, if I put it back here, it's not anymore. All right, so now let's actually start working on the game. And we're going to create two scenes. So in KAPLAY, the way you create a scene is by calling the scene method or function and then giving it a name and then passing as the second param a function that is going to contain the logic for that scene. So we're gonna need two scenes. We're gonna need the first scene called start, which is the menu, and then the second scene, I'm gonna call it main. It's going to be the actual content of the game. And then I'm gonna call the go function, which will go to the start scene when the game starts. So start function, main function, and start scene, main scene, etc. So I'm going to write a new file here. I'm going to call it utils.js. It's just going to contain a few utilities that are going to be used. For now, we're just going to create a function that makes the background a certain color. So I'm going to call it make background. I'm going to pass in the K context, so I don't have to import K everywhere, which is the KAPLAY context. And then I'm going to call the add function. So the way KAPLAY works is that you create game objects using the add function and passing it an array of components. So the array of components you pass in, which usually are components that are offered by KAPLAY, they will then come together to create a game object with specific behaviors and properties. So here I'm going to use the rectangular component from KAPLAY. I'm going to call the width method and height method so that this rectangle takes the full height and width of the canvas. I'm going to set the color by using the color component of that rectangle. So I'm going to set the color using the color component for the rectangle. So it's not a color component of the rectangle. It's just a color component offered by Kaboom that allows you to modify the color of a game object. So here I'm going to call the fromHex method, which can be accessed like this and allows us to specify a hexadecimal value. So by default, the color components takes RGB values, which mean 3 params that can vary from 0 to 255, but we want a specific color, and with a hexa, usually in pixel art or in art, you use hexadecimal instead of like RGB to specify colors. So that's what I prefer to use. And then finally, we're going to have a last component from KAPLAY again called the fixed component, which will make the which is going to make the background independent from the camera, because the camera is going to follow the player. But by the way, I think this is useless because in a Flappy Bird style game, the player never moves actually. They just jump, and it's the platforms that moves, or the obstacles that moves towards them. So this component is not necessary. So let's use that in our first scene, the start scene. I'm just gonna call it make background and pass in the K here, context that comes from here. Now if I look at the result, you can see that here we have bars here that are just the black bars, and then you have the appropriate color. I prefer my black bars here to be black and not white. So here in the body, I'm just going to have a style tag. We're not going to spend too much time in CSS, just one thing, body, a selector, and then set that to being background color, and then black. So now it will look much nicer. Yeah, I think this is better. So now what comes next is to actually draw the background. So I'm going to create something called a map game object. It's going to act as the parent of all the game objects that are props or obstacles, clouds, etc. They're going to be all children of that singular map game object. So this is a feature that KAPLAY allows you to do, is to create game objects, but also to have child game objects and parent game objects. So here we create a parent game object like a usual game object with the add function, and we pass in the following array of components. We can use the sprite component offered by KAPLAY, and then you specify the key for the sprite, which was defined earlier on in the load sprite function. So here I'm going to have the background as the sprite I want to use for this game object. I also have access to the positional component, which allows us to set the position of our game object, here 0, 0, because it's the background, we want it to be at the origin. And by the way, in game development, things are drawn from the top left corner, unless you specify the center to be the origin of the sprite or the game object. And then finally, I'm going to actually scale our game here. So here I'm going to create a constants.js file, constants.js. I'm going to export const, and I'm going to call it scale factor, because the pixel art is going to be too small. So for things to be visible, I'm going to have to scale things a bit. Now you have two options actually. Either, let's scale it 4 times. Either you make the camera zoom in, or you make the sprites scale. So either one should work. So scale factor is going to be the thing I'm going to use here. Don't forget to import it, or otherwise you're going to have an error. So I'm going to import scale factor from constants. Now, did I get this right? Export, yep, should work. Okay, now let's go back to main. So we should have our game object. It should appear on the screen. And you can see that we have our background. It looks pretty nice. Now we're going to have to add the clouds. And the way I'm going to go about this is I'm going to create the clouds as a child game object of the map. So the way I do this is by having a call to map.add. So every game object has also the add function as a method that allows you to create game objects, but this time they are a children of that game object instead of a global game object. And here I'm going to again have a sprite component with the clouds. And when you create a child game object, what happens is that their position is relative to the parent game object, which is pretty handy. Here, however, we are going to need to call the positional components so that we can have access to the position and be able to set it. If you don't do that, you cannot modify the position. So even though I don't need to specify a value here, because I just want to later on modify the cloud so they move in a certain direction, I still need to call the sprite, the positional component. And now the last one, I think here in Kaboom.js, what's handy and allows you to get away with not using classes, etc., is that each game object can have as part of their array of components an object which you can specify in its properties. So here I'm going to specify the speed property as being 5. So it's going to be the rate at which the clouds are going to move. So here I'm going to store the reference to those clouds here. Because by default, when you create a game object using the add, it always returns that game object. Even as a child of another game object, it will return the child game object. And here we have multiple clouds and not just one under the same image. So that's why it's the clouds game object and not every individual cloud as game object, which is better for performance reasons. So here what I'm going to do is I'm going to use one of the other methods that are available is the onUpdate methods on every game object, which runs this function every frame. So usually 60 frames, 60 times per second. So here I'm going to use the clouds move method, which is also offered by KAPLAY on game objects, which allows you to just move a game object along the x and y coordinates at a certain rate. So here I can use the speed I've defined earlier on and access it like this. So the game object name dot the property. And then here it's going to be as the first param. That means it's going to move along the x-axis, positively, so to the right. And then for the y-axis, I don't want to change the speed, so it's going to be 0. And now here right below, what we're going to do is a clever trick. So for now, if I run this, the clouds are moving to the right, and then once they are fully gone to the right, they will never come back. So what I'm going to do is I'm going to use a clever trick, is I'm going to make sure that once the clouds position clouds.pause, you can access the position this way, and that's why I needed to use the pause component. If you didn't use that, you wouldn't be able to access the current position. So if the clouds.position is .x, because it offers you both the x and y value, but we only need the x value, is superior to 700, which is when they leave the frame, the visible area of the canvas, then we're just going to set back the position of along the x-axis to be of -500. The reason we do this is they go all the way back to the left immediately. They teleport back to the left, and then they will continue their movement. So basically we have infinite clouds that go from left to right. So if I go here, now here I'm not going to wait for this to be done, but you'll notice it while playing the game, the final game, that as the clouds move to the right, and they moved fully to the right so that they are no longer visible, they're going to appear back from the left because they're teleported back. So now the last thing we need for that scene is to add the obstacle as another game object to the map. And here we're going to need the sprite obstacles. So the obstacle sprite, and I think that's it. And by the way, because initially we scaled the map game object, the parent game object, everything else, the children are also going to get scaled, by the way. Forgot to mention that. For the last game object, the obstacle game object, we're going to have to specify the position as well by using the position component, but not necessarily passing in a value, because we're going to modify this value later on and read it. And here we're going to use the area component, which is also offered by KAPLAY and allows you to specify a hitbox for your game object. Actually, you know what? I think it's not necessary here because the hitbox is going to be dependent on something else. But for this, yeah, here in this case, we don't need it. We don't need it. You're going to see when we're going to need it later on. And that's it. Or maybe, yeah, that's it. I think that's it. So yeah, we don't need anything else. So if I look at the app, you can see. So basically what we're building here in the start is the start menu. Basically, that's it. So we're going to put the Creepy character here and the play button. And then actually in the main is actually where we're going to write the actual logic for jumping, etc. What we're going to do now is create a player.js file, which is where we're going to write the logic for Creepy, the main character, so that we can reuse that in both the start scene and the menu and in the actual game, so in the main scene. So I'm going to create a function which is going to act as the constructor. It's going to be called makePlayer, and it's going to take in the context. And then here we can use the make method from KAPLAY, which what it does is like the add function, but the only difference between make and add is that make creates the game object but does not display it on screen. Later on, we're gonna add, if you make an add call to a make to the result of that, it's going to actually create it. So for now, we're just focusing, sorry, with creating the game object itself. So here I'm gonna use the sprite component with Creepy, so that this is what is displayed. Here we're going to have an area component, which defines a hitbox, and you can pass in an object with the shape property to specify a specific hitbox shape. We're going to have a rectangle. You can create a rectangle by using the k.rect with a capital letter in KAPLAY. And the first param is the y and x position relative to the game object itself, and you can have this as a vector2. Vector2 is just going to be in x and y coordinates as a single data structure. So here we're going to have 0 for the first param and then 1.5. So that means the hitbox is going to be placed at the position 0 and 1.5 relative to the game object. And then the second and third param of the rect method or function is just going to be the width and the height of that rectangle. So here the width and height is going to be 8 by 5. So Creepy, the character itself, is 16 by 16, but by having this hitbox being 8 by 5, it's going to be more generous since it's a hard game, and it will reduce the amount of rage that the player will experience. And then by default, I said earlier on that in KAPLAY or in game dev in general, things are drawn from the top left corner. But in this case, it would be better for things to be, so the player game object to be drawn from the center. And you can specify this by using the anchor component offered by KAPLAY and passing in center here as the string. To use this, you need to have the area component defined. Otherwise, you're going to get an error. And then finally going to scale the character as well, this game object, like we did with the other one. And this is where we can use our constant again here. And then finally going to have an object here, which is going to contain properties and methods that are useful for the player. So here I'm going to have first an is dead boolean, initially false, which we're going to use here to know when to display the scoreboard. and when to restart the game. And then the speed is going to be 600, which is the value that felt nice. I'm going to have a key controllers array here, which is going to hold event listeners to the various input controls we're going to define. And the reason we're doing this is because when the player dies, we want to cancel all those controllers, and by having them in an array and then iterating through them, we can disable the player controls so that the player can no longer move once they die. All right, so now let's create our first method, which is going to be the setControls method here. This is arbitrary, and by the way, if you're not familiar with this notation, it's equivalent to having this like that, which you might be more familiar with. So this method, I'm going to call it setControls. Its goal, as its name suggests, is to set the controls. This is not from KAPLAY. This is just a name I've decided to call this function. I'm going to call it later on. So here, I'm going to store the jump logic that I'm going to write into a simple small function. So because it's a small function, by convention, I'm going to use the convention that if it's a reusable piece of logic that you're not going to use elsewhere, I'm just going to use this notation for the function, and otherwise I use the function keyword. This is a personal preference, and you can feel free to do what you want. And here we're going to play the sound. So here in main.js, we imported the sounds for the various situations. So when the player jumps or gets hurt, and here when we set the control, when the player jumps, we want to play the jump sound, which we can use the key here of. If you remember main.js, the jump sound is here. And yeah, to play a sound, you call the play method from the KAPLAY context. And then here I'm going to use this dot jump, and this might be confusing. Where does this and jump comes from, and why a comma here? So that's a mistake on my part. So this can be used to refer to the whole game object. So when you create methods within this object here, you have access to the actual all of the game object, which is pretty handy. That means that this refers to the game object itself. Now jump here is offered by KAPLAY. It allows you to automatically implement jumping, and I realized that I forgot to add the body component. So this jump method comes from the fact that we used the body component, which we didn't. So now it's time to add it. So the body component allows us to make our game object susceptible to gravity, and also allows us to have the jump method, so which implements jumping automatically for us. You can modify various properties either within here, the jump, or within the body component itself. Here I'm going to set the jump force to being 600, and there's the mass that you can modify, etc. By the way, go to the kaplayjs.com. Go to kaplayjs.com, which is where you're going to find the documentation for KAPLAY. So we have jump force, everything is fine, and then let's actually implement our jumping. So here I'm going to use this .key controllers, and I'm going to push to it the various event listeners we're going to create. So here we have access to the following. So this on key press. Well, actually you can use a global k on key press, and I don't remember why I did this way, but I think it's more performant to, actually I don't see any reason to use this here. So use k here, and then on key press, which is offered by KAPLAY, you can have an example here. You pass as the first param the key you want to use, and the second param is the function that is going to run when this is pressed. There is another way of doing it where you only have one param, and you have the key param here. It's going to give you every key, which is a more handy way and better way to do it. But because in this project we only have one input, really, then this way is fine. Watch my previous adventure platformer tutorial to know how to use more advanced feature of KAPLAY. It was called Kaboom then, but everything is applicable. The same knowledge basically. So here space, and then we're gonna call the jump logic. So we're gonna pass the function here. So this is going to result in an event listener controller, and this controller is when the space key runs, it fires off the jump logic function. Now, as I said in the beginning of the tutorial, we will have more than one input method. The other one is the click. So this key controllers push. Maybe key controller is not the right word here. Maybe I should call it input controller. Input controllers would be a better name, because it's not only for keys in the keyboard. So here we can use the onClick method from KAPLAY, and you can just pass in the jump logic here. It's going to fire the function you pass in when the player clicks. And then finally, we're going to push the one for the gamepad. So for gamepad, you have KAPLAY offers you the on game, what's the name? On gamepad button press. On gamepad button press. And then you specify the south, as I've explained earlier on. South comes from the fact that if you look at the controller, this button is to the south, basically. And now here, the second param is the actual logic. So jump logic, that is going to fire off. All right, now we're almost done. I'm going to collapse the set controls here. I'm going to call the disable controls, which is going to be called, not dispatch events, disable controls, which is a method I created. I decided to create those function. It's not from KAPLAY, just making sure that you understand that. Here, disable controls, what it's going to do is just going to iterate through the key controllers. Actually, now it's called input controllers, and then for each, you could use a more performant for loop, but it's only 3 elements, so it's not that useful. So key controllers, and then arrow, and then key controller. For each key controller, we're gonna call the cancel method, which is available on each of those controls. So if you look at the documentation, I click on keep. There's no IntelliSense, it seems. Anyway, these calls return in event controller. All right, so now in main.js, I'm going to, right below here, let's add the player. So const player, and then we're going to call the add function, and within we're going to call the make player function that we defined earlier on, that now should be imported from the .player.js file here. So now what I'm going to do here is remove, first pass in the K here, the context, so that we can have access to the various Kaboom methods. And then in here, you can modify the position like this and as a vector2 like that. So you can use the vector2 method to create a vector2 on the fly. And then here, we're going to put it at the following coordinates. So I'm going to copy and paste this because it's not really that relevant. I'm just going to explain one thing here. So here, k.center gives you the center position, and you have access to the x and y coordinates of it. And here we just make our Kribi character relative to the center position by a few given offsets here. This is what looked good. So if I look at the result, it's here. Wait a minute. So something went wrong. I'm just going to do F12. And here I have let's go to the console, and then the body require, okay, we didn't use the positional component, so I forgot to add this to our definition of the player. So now if I run this again, you can see that the Kribi character is here, which is what we want actually, by the way. And now the last thing we have for this start menu scene is the start button, and when it is clicked, or when the player presses enter, or when the player presses the south button on the gamepad, we should start the game. So here in main.js, we're going to have to create a play button. So here we're going to do it the same way. So I'm going to create a constant called play button. I'm going to create a game object out of it. And here there's no new concept, so I'm going to copy and paste the code. Feel free to pause. There's one new concept, is the radius. So when creating a rectangle. By the way, this is the rectangle component, creates a visible rectangle. Do not confuse this with the hitbox k.rect. This is not a component. This is just creating a rectangle hitbox. So there's a difference between the two. So when you want to create a rectangle that is visible, you use the rect component from KAPLAY. When you want to create a rectangular hitbox in the shape, you use the k.rect here. All right. So a radius of 3, so it's well rounded. And then here we're gonna add a child to the play button. So right below here. And it's going to use a new component that you're not familiar with if you haven't used KAPLAY before. It's the text component. It takes as the first param the text you actually want to display, and the second param can take the size, the font, etc. Here we just want the size. So the size is going to be 24 with this given color. So it's a darkish color, which follows the palette I used for the assets. All right, so now everything should be here, should be fine. Let's look at the result. We have the play button, but if we click, nothing happens. If we press space, nothing happens. So here, I'm gonna use the same pattern we used in for the set controls for the player. So I'm gonna copy and paste, create a disposable, I guess, small reusable piece of logic function here using this convention. It will play the confirm sound and then go to main. Main is the other scene, which is actual game. And then we hook this up to the various input methods. So on click, on key press, on game button press. All right, so now it's time to write the logic for the actual game. Here, I'm gonna create a constant. I'm gonna call it score. It's going to be initially have 0. So, yeah. And by the way, one thing is we're gonna implement the save system right now, actually, instead of writing logic here in our start scene. So let me just collapse it just to have a clearer picture. So yeah, I'm writing in a very big font so that you can be like really see the code, but it's kind of inconvenient. So we're gonna have to define our save system. So I'm going to create a file called save.js, which I'm gonna write the logic for that. How we're going to go about saving our score. So the pattern I used for this is something very simple. What I do is I create a function called make save system. It takes a save file name you want to use for the game. And then within it returns an object. This object has first a data property, which contains the data we're gonna save. It's going to contain an async method called save. It's going to contain another async method that is going to be load. The reason those are in async is because we're going to call the Tauri API within, and the Tauri API is asynchronous. So here in our save function, what we're going to do is we're going to call the write text file method from or function from the Tauri API. This is something from Tauri. It takes 3 params. It takes the save file name, so the actual name, the path, or actually the save file name, not the path. And then here, actually it's 3, the content, and then so it takes the name of the file, the content, which is just going to be a JSON.stringify. So we're gonna convert our data here. So we're gonna use this.data into text, and then the final one is going to be the base directory. So the dir, it's an object that you need to specify the base directory, and then app local data. This is how you're going to be able to write the data here to the save file name, which is going to be save.json, and along the base directory app local data. If you weren't to not use this, it wouldn't allow it. And here base directory is imported from here. It's an enum. And app local data is basically like the folder I've shown you earlier on. All right, that's it. That's how you write to a file. And if the file didn't exist before, it's just going to create it. And if it already existed, it's going to overwrite it. So you might need to append in certain situations, but for our project, we can just overwrite when the score that the player has acquired in the current game is higher than what was written on disk. And then the load function here is we're going to have a try catch, because we might attempt to try to read a file that doesn't exist, especially when the player first opens the game. Well, the goal of this is that we will store into the data property that we created here the actual data, so JSON from the file. So we're going to use JSON parse, which is going to parse the text, the string that we stored inside of our save.json file. So here we're going to call the await read text file API from Tauri, pass in the save file name, and then the second param is just a dir. So dir directory, base directory, and then app local data. And then if for some reason it's not possible, and this occurs when the file doesn't exist, and it happens when the player first install the game for the first time, or they installed the game in the past, uninstalled it, and then removed the save file from the local folder, then what we're going to do in this case, we're just going to set the data property from within the game to an empty object, and then when we're going to save, we're just going to write to a new file, to the file, basically, to a new file, because it didn't exist. All right, we have everything we want here. So now we're just going to export our save system. So I'm going to have a constant, call it save system, which is going to be, we're going to call the make save system, and we're going to pass in that we want to store this in save.json. So when the player opens up the game, they go to the start scene, and at the end of the start scene, we're going to call our save system. This should be imported from our file, just to make sure save system has been imported. And then here, what we're going to do is we have save system, and then we're going to load. So initially, if the file didn't exist, then we're going to have an if statement, which is going to make sure that if the save system dot data max score, which is a property that doesn't exist yet. By the way, it doesn't exist yet. So I'm assuming, like, we have the player, they open up the game for the first time. That means there's no data. So we load the data from our save system, and this is going to go into the try catch, is going to be catched because it doesn't exist. You cannot read a file that does not exist. That means that the data is going to be set to basically the default. So when we arrive here for the first time after having loaded the data, then the max score property doesn't exist, and this is where we're going to actually set it. So save system dot data dot max score, we're going to initially set it to 0. Then we're going to save that data that we just wrote into the data object to disk by calling the save method, and then reloading it to actually, this is not necessary to reload it here, but because we just write the same thing, and then we don't need to reload it. So I'm gonna not need that. So here we go. And the reason I'm doing this is just to make sure that if the player opens up the game for the first time, we have actually a max score property that is created in that save.json file. All right. So now let's write the meat of the game, which is the main scene. Here, I'm going to have a variable. I'm going to call it score, which is going to increment as the player is surviving and avoiding the obstacles. Now, the next thing I want to do is I'm going to import the colliders data. So I'm going to use an await and an await and then fetch. And then the reason I'm doing this is to fetch this colliders data. So here I'm just going to do dot colliders data.json, and then once you receive a response here, you need to await the response, and then you need to await again while it is converted to JSON. Usually people do this in two calls. They first store this into a response constant and then call .json on it. But I prefer to have it on one line here for conciseness. And then here I'm going to create colliders data, and it's going to be the colliders object data. And the reason it's data is that if you look at the colliders data.json, it's a data property with an array, and we were only interested in the array, so that's why I'm storing it as its own constant. And then I'm going to call make background. By the way, this should probably be called at the top. The first thing we want to do, because the background we set here is dependent on each scene, so you cannot have a global background that you can set. Well, actually, you can use the set background, but the issue with the set background is it doesn't respect the aspect ratio, the letterbox. That means that if you call this method from KAPLAY, it's going to color even the place where it shouldn't be, like the black bars, so it doesn't respect the aspect ratio. All right, so we have the make background here, and yep. So now what comes next is we're going to use set gravity, so that the player is going to be affected by gravity. The value, the G value that was that felt nice was 2,500. Set gravity is a method from KAPLAY. So yeah, by the way, if you see still Kaboom context here, it's because it was previously called Kaboom. All right, and then here the logic is going to be very similar to what we had initially. I could have abstracted this into a function. By the way, I noticed something is I called this map. You could have called it level, and then later on in my source code on GitHub, I used level here, which is inconsistent, and I should probably do better. So I'm going to just copy and paste here, so this first part, and just for the sake of consistency, let's use map everywhere because it's the same logic, copy and paste it basically. So here you could create a function that takes care of all of this. I'm not gonna do this just to go faster because the main draw of this tutorial is really to teach you how to have this all as a desktop app, not necessarily the game itself. If you're interested in more like code organization and tutorials where I take care more of that, you can see my other tutorial, watch my other tutorials. So here we have, okay, so I replaced it with map, and then here, we're gonna have the platforms like we did initially here, and instead of level, it's gonna be map. And then here it's different logic. So actually, never mind. Yeah, this is a different logic. So here we also had the platforms. If you go to the logic we had for the start menu, we had clouds, we had actually, yeah, we had the platforms here. But now we need to actually do something with the platforms. That's why I store them inside their own constant. And then here below, we're going to use the onUpdate methods that is called every frame. And here I'm going to make all the platforms move. By the way, the platforms are just a single big image, so it can be treated as a single entity. It's not multiple sprites. So here, the move function, we're going to move to the speed platforms.speed here, and then 0. And then here is going to be something else. So we're going to use the same logic that we used for the clouds. So we're going to have, as long as the position is inferior to a certain value, well, as soon as the platform's position is inferior to a certain value, we're going to replace the platforms to being to the right and then we progressively increases the speed so that it is a challenge for the player. So here's the comment I left here. By the way, the source code is available on GitHub. It might be a slightly different from what I'm writing here, but you can use it as a reference. And then here we have this now, and we can have the loop method, something from KAPLAY. So every second, it's going to run the function passed as a second param. And here we're just going to increment the score by 1. Simple way to calculate the score. And then here is where we're going to add the hitbox to all the platforms, or the obstacles. Maybe obstacles would have been a better name since it's the name of the sprite here. But initially I wanted to make a Kirby-like and then teach you how to use Tauri, but I thought it would be like too complicated, and it's better to isolate and do something simple so that you can be familiar with how to make like desktop games. All right, so here as I said, our obstacles are a single image, and by using the collider's data, we're going to know where to draw the hitbox for each of those obstacles within that image. So we're going to create child game objects of the platform's game object. So here, I'm going to use a for loop for const collider of collider's data. We're going to add for each of them to the platform's game object. We're going to add, so the platforms is a child of the map, and every collider here is going to be a child of the platform, so that their position is relative to the platform, the obstacle image. That means when this image moves, all the colliders are going to move at the same time without any extra logic from our part. And then here, it's the same thing, so I'm just going to copy and paste. Actually, there's one thing different. Is static. So here we create a hitbox with a rectangle with a collider width and collider height. This comes from the JSON file, which has these values. We place the position X and Y. This is going to be relative to the platform, the obstacle image, which is what we want. And then here the body, by setting the isStatic property to being true, what will happen is it's going to be solid so that our player cannot pass through, and it's going to act as obstacles. All right, now we're going to need to create 2 other game objects that are going to sit at the top and bottom of the screen. And those 2 game objects outside of the for loop, but still in the main scene, are going to act as walls up and above. So here it's the width, the rectangle is going to be the width of the whole screen. One is going to be placed at the top of the screen, but not visible, and the other as well. And we don't need them to be fixed since we're not going to modify their position. The player position isn't moving at all anyway. Oh, by the way, never mind. I think actually we might need this. Anyway, let's keep it for now, and then I'm gonna remove it if it's not necessary. I'm thinking of an edge case, but it might not be actually a case. All right, so now if I look at the result, you can see that we have nothing for now, but the platforms are slightly increasing in speed. So now let's call our player. So const player make player pass and decay, and then right below player position, the position that sounded nice, looked nice, was 600 by 250. We're going to set the player control so that the player can start moving. And then we're gonna use KAPLAY's onCollide logic. So when this onCollide method available on GameObject is that when the player onCollides with this. So by the way, I forgot to explain what is this. This is a tag. You can set it so that you can use them later on in onCollide calls to check for collisions. So here, onCollide, when the player onCollides with the tag here is going to be the obstacle. So every game object that has this tag is concerned by this method. that is going to fire. So basically, when the player collides with the obstacle, this runs. What will run here is first we check if the player is not already dead. So player is dead. Make sure that this is, if it's true, that means we don't run the logic that comes afterwards. And then we play the hurt sound. Then we set the platform's speed to being 0. And because of that, because we set the platform, I don't think fixed is necessary because the player is not moving, so the camera is not moving at all. So let's set it to like that. So platform speed is going to be set to 0. Then we're going to disable the player controls. So disable controls of the player. And then here we're going to have to do and create score box. And then set player is dead being true. So let's play our game. Okay, where's the player? By the way, you can use the F1 key to open the debug mode. Oh, I think I know. Because we called the make player, we didn't add it to the screen. So you need to call it within a add. Because make player uses the make function, which creates the game object, but doesn't actually add it to the scene. So now it should work. So if I go here we go, we have our game. So let's on purpose hit and then nothing happens. Okay, now if I refresh again using F5 and I go to the top, yeah, so those walls that are not visible are here to prevent the player from going out of bounds. So, yep. And here, where are they? Yep, so those are the walls, those two game objects here. Okay, so the last part is really to create the scoreboard. So I'm gonna, the score box, not board. Well, it could be a board. Scored box.js. So here we're gonna have an export function and then make score box. Takes the context k, but it's going to also take a position, I think. Yep, it's going to take a position, which is going to be a vector 2, which is going to have x and y coordinates, and that's it. And oh, of course, one last thing is the actual current score. And now here we're going to use the save system, and we want to load from the file the save system, because we're going to have to compare to the actual max score. So making sure to read the file that we have saved so that we can do the comparison here. So if the score is superior, the current score is superior to the save system dot data dot max score. If that's the case, then we're gonna put it in the save system max score, the new maximum score, and then we're gonna call await and then save system, and here is actually where we do the saving. So we're gonna call it save. By the way, this should be async, so we can use await. And this is the actual thing that writes to disk. So maybe I should have call it save system.write and read, but I think load and save are pretty understandable terms. So now let's create our box, and here I'm gonna use the make function as well. So here, the make function. And the reason I want this fixed though is, yeah, because here it's important to have it fixed, independent from the camera, because depending on where the player is, but actually, never mind, the camera shouldn't even be moved in the first place, so there's no need for that. So here, nothing new, except for the outline component, which creates an outline, and we can give it a particular color as the second param. This is going to be the outermost container, and then we're gonna add as child game object the various text we need. So this is something I'm going to just copy and paste because it's tedious to write. Here we go. Let me just go up so you can copy. So this is the previous best score text, which we take from the save system and a given position, etc. Here, same thing for the current score. And then the current rank, which actually we didn't write the compute rank method function. So yeah, let's just copy this for now. Those two. Hit pause. And maybe like that. Can't see everything. Now I'm going to go in utils, and the rank, compute rank, is just going to give a rank depending on the score value. So here, export function, compute rank in utils, and then you pass in the score. And then depending on the score, we're just going to give a letter-based grade, so the rank. And here I'm just going to copy and paste the logic. It's just a bunch of if statements. Maybe you should have used them. Maybe I should have used a switch case here, but yeah, so if the score is superior to 30, S rank. Superior to 20, A rank. Superior to 10, B rank. Superior to 2, C rank. And D if you have 0, 1 or 0. And that's it. So now if I go back to the scoreboard, score box, let's import the compute rank. Import compute rank. And yep, so now it should compute it. So if I play the game, by the way, I did not call the scoreboard, but we haven't finished. We haven't finished. We need to do the following. We need to create the restart button and the same logic for the restart button, and then return the container, which is the whole parent of the box. So here we have this restart button that as a child of the container as well, which is going to be a rectangle with this color, and then it's going to be drawn from the center. Nothing new here, no new concepts. And then here, as a child of the restart button, I'm gonna have the text play again with the following size, etc. And then here I should have followed. This is just a real reusable piece of logic that isn't used elsewhere. Actually, it is used elsewhere. It's not the first time that we have something like that. But I think it was different every case, right? Here it's jump logic. And I think it was used where it was used. It was used here, right? Go to game. So maybe this should go. So we have this here. Let's take this. Let's go to utils. Let's create another utils. Let's write it as a proper function. Well, they're both proper function. I mean, like with the function syntax. Let's go back to main. Let's just... the issue now is that we need to use an arrow here. And then call and pass in the K. And then an arrow here. And then pass in K. And then an arrow here. And then pass in the K, because we don't want the function to be called immediately. If you were to pass it and it would be called with the parenthesis, it would call it immediately. But we still need to pass the context, so that we need to wrap it inside of an arrow function definition. So that's that. And then at the above, let's go to utils here and add it. Go to game. That means in our score box, I can just remove that. I can go above. I can import it. Go to game. Here we go. And here we go. So we have the on clicks, etc. So on key press, the various inputs. This again could be abstracted away, but I want to keep things simple for this project. And then finally, we return the container, which contains everything. So the whole score box. And then in main.js, if I scroll down in the to-do, we're gonna call k.add score make score box, pass in the context, pass in the following position. I don't remember the actual position I used. At the end of the day, we just pass in the center, k.center here, position, which is, well, I should have probably hard-coded it here in score box if it's the center, but imagine in a future use case where we want to display more components like that score box in various different places, so it doesn't hurt, I guess. And then finally, as a third param, the score that we had in main here. We had defined it above here in our main scene. All right, so that's basically it. And now I think our game is done. Yeah, I think our game is done. So let me check. Okay, we have a mistake. Does not provide a go-to game score box. Yes, utils does not. If I go to utils, go to game, and then if I go to the score box. Okay, because we need to wrap it under a arrow function. I'm just gonna copy and paste this. Save. All right, now things should work. Yeah, so I didn't read the proper error message. So what's the issue? Syntax error. The requested module source utils.js does not provide an export name go to game. Is that true? Yes. Export. Sorry, I missed that. Now if I go here, we have our game. And then let's die. And okay, what is that? A W trigger is not a function? What do you mean? Okay, I made a mistake somewhere. Oh, I know why. If I go back to main, here, remember this was an await. Here we return a promise, so it's trying to add a promise as a game object. It doesn't work like that. So we need to use await here. Okay, wait a minute. Only allowed within async function, but this needs to be async. So the scene itself needs to be async. Not the scene. The on collide callback. So that means we don't need to have here as async. We need, because we needed to make a fetch call to the JSON file, which contains the collider data. All right, so I think that's it. Previous best score 3, current score 1, previous best rank C. So let's try beating our score. Here we go. We have CC as the rank. Okay, let's try for 20. At the same time, we're gonna test a few things. So, all right. 15, current rank B. So next time, if I die here, previous best score 10. Okay, it's not doing it right. That's probably due to the fact that here I did not load it in the main, in the start, scene. If I go to where I set up the save system, I did not load the save system here. I need to load here as well. Now the last part of the tutorial, it's basically getting the executables, getting ready to distribute the project. So I'm gonna close the project, and then you're gonna write npm run build. So now it's going to build the project. It's gonna compile, and this is going to take maybe a lot of time at first. When you do it for the first time, it's the first time building the project. So let's wait. All right, it's almost done compiling. And as I said, this compilation step takes a lot of time the first time you do it, but then it's relatively quick afterwards. So now there's only one thing left, and here we go, running and then producing the MSI, which is what is useful to distribute. All right, the project has been built after a long time. Now, to get the executable, you can go here to source.tari, target, and release. And then in bundle, this is what you want to distribute, either the MSI or the NSYS. So either one of those two should be fine. The reason I want you to distribute these instead of the kirby.exe file is that these are installers, and if the player is either playing on an older machine and doesn't have the WebView 2 system installed on their machine, then the installer is going to take care of installing it for them. All right, so yeah, just distribute that on itch.io or Steam, either one of them, and that's it. This is how you make a desktop game in JavaScript. All right, thanks for watching. I hope this tutorial was useful for you, and yep, that's it. Feel free to subscribe for more JavaScript game dev related content. Bye. I forgot to mention something very important in the project is that if you want your executable, so once the Tauri app is installed, so when your game is installed on a user's machine, if they hover over it and this short description property is not defined, it's going to display a Tauri app. And I would assume you want a description of your project to appear and not a Tauri app. So to have this description, you need to go to tauri.conf.json and then under the bundle, add the short description and your description here. So that's all.